But yeah, it's 1 minute past now. I do expect more people to join us, but let's crack on. Let's
Okay.
start with your presentation. And all I wanted to say to the attendees, hi, I'm Raminta. I chair our MQ stream, and who has attended GSE sessions in the last couple of years probably have seen me in MQ promoting and talking things on it. So very welcome. We have our first presentation in MQ stream today, and it's what's new in MQ. Neil will be presenting that. He will introduce himself a bit more as soon as I'm done with my initial spiel. But the only thing that is worth mentioning that Neil has very kindly agreed to take the questions as he goes, but I will encourage the participants to put the questions in the chat so we can address them maybe in the end of the session, and we can have some sort of discussion if that's required. But other than that, very welcome again, everyone. Thank you very much for your time, and thank you very much for Neil for presenting, and the floor is yours.
Thank you. Right. So good morning, everyone. So I'm Neil Johnson. I work in the MQ for z/OS development and service department. I mostly work on sort of level 3 stuff these days, but I've been in IBM working on MQ for over 25 years now. So I've done a few things over the years. So yeah, so we've got about 45 minutes today, and we're going to go through what's new in MQ. So there's quite a lot of slides in this. So I'll try not to waffle too much. So where are we now? So it's worth mentioning the delivery model for MQ in case people aren't aware of it. So back in the version 9 days, when we turned to version 9, we moved to this concept of doing continuous delivery, where every 4 months or so we bring out a new release of MQ that's fully supported. But it's the continuous delivery releases, and they don't remain supported for terribly long. You certainly won't get fixes on them for a long time. So we also have the LTS stream, the long-term support stream, which is essentially what, certainly on mainframe anyway, what most customers will use. And that will give you a new release with what's now called 5+1+3 support, which is a newish thing that came out with recent LTS releases, where essentially you get the 5 years of support on LTS releases that you've always had, plus an extra additional year of critical fixes. So that's any sort of security fixes and things like that. And then usage and known defects and existing fixes for another 3 years after that. So in the current timeline, we're on around, the most recent release was 9.4.2 a couple of months ago. So you can imagine there'll be a subsequent release coming before too long, but the 9.4 LTS came out last year, and that's what most people will use for production environments. So for multi-platforms, I talk about all the platforms here. So I work on z/OS, but MQ obviously people are normally interested in what's happening on all the different platforms. So I'll just highlight a few things that have been happening on what we call the distributed or multi-platforms at times. And so there's and this is just the 9.4.2 release, sorry. So this is just the latest things to come out. We've got sort of support for the new IBM Semaru, which is the newish name for the IBM Java environment. They've got some FIPS compliant security provider. We've added this JWKS support for automatic certificate management. We'll talk about it a little bit later. MFT's added support for OpenSSH private keys. We've made console enhancements. We've brought out this performance monitoring enhancement tool, the MQ-Perf CK utility in 9.4.2, and we've also retrofitted that now, or at least we will be very soon via an APA to other LTS releases, which essentially does a health check or a mini sort of health check and performance check of your Queue Manager environment and generates this HTML report that you can look at and give you some other information. We've also done various things like upgrading the Kafka source and sync connectors, and we've also got quite a large thing, which is the native HA, which is the high availability running in containers and clouds, cross-region replication in containers, and we will talk about that a bit more later. There's some other little things like multiple JMS connections can now be treated as a single application instance. So there's a VM configuration option that allows you to make it appear that the various JMS connections are all part of one channel under the covers, which allows you to use some of the channel efficiency configuration settings like ShareConf for those, even though they are potentially different connections, as long as they're coming from the same virtual instance of MQ. or the application, sorry, I should say. And we simplified some of the configuration things for MQP and TT properties. On the appliance, we've added some multi-factor authentication support. There are certificates that you can use to log in for console and REST, and there's some external user authentication to provide a consistent experience. So on MQ for ZOS, we've added, there's been a lot of enhancements around the MQ console, which is the new web interface that you can use to administer and monitor MQ. We'll see a bit more about that, but we've added capabilities to look at add, view, delete, and update coupling facility structures, which are a very specific ZOS component in MQ that allows you to use shared messages in a ZOS coupling facility. You can look at SMDS datasets. Those are the datasets that you use for shared messages in a coupling facility, when using a coupling facility to offload messages to give you additional queue space. And there's some additional tweaks and options and support for the GB18030 22 standard, which is very popular or a very common conversion CCSID in China. So here's a quick view of the console. We've added some various options. They let you now, like I said, look at application and admin structures and things like that in the coupling facility. You can also view SMDS datasets, and you can also customize which columns are displayed. So you get a bit of sort of customization capability with this now. So what's new in 9.4 LTS? So that was kind of 9.4.2, which is the latest, very latest CD release. So if you look at what's new in 9.4.2, this is over and above what was in 9.3 LTS. So these are all the new capabilities, and you'll be pleased to know I'm not going to go through them all one by one, but this slide is there to kind of give you a feeling for the kind of work that's going on within MQ. Lots and lots of not necessarily every feature is a huge new capability. There's lots of tweaks, enhancements, additional options, and things like that. And we'll talk about some of the more important ones as we go on. It's always worth mentioning things that have been deprecated or removed. So the REST API v1 is deprecated and replaced by the REST API v2. We'll talk about that a bit more. The Salesforce bridge has been removed from the advanced product. You can achieve most of what it was capable of achieving with ACE nowadays. So I don't think there was a huge uptake in that, so that's been removed. The MQ classes for .NET standard library have been deprecated. It were deprecated in 9.3.1 and removed in 9.4. The classes for .NET framework are still provided. So there's some other changes around .NET and XMS. One thing that's worth highlighting is that SSL v3 and TLS 1.0. 9.4 LTS is the last MQ release that's going to support SSL v3. Pretty much everyone who cares about security should have migrated away from that, but there are some people who are using it in some edge and corner cases. Well, at some point, it's going to become impossible to use it. So this is kind of a warning that that's coming. And we're also getting rid of some of the older, less secure encryption options from AMS, which again, it's not recommended you be using them, and they will be sort of disappearing. So what are some of the new capabilities and features that are in MQ? So observability is one area that's quite important within MQ nowadays. So that's the ability to look inside a queue manager and see what's going on, or look at applications and what's happening performance-wise. If you get some slowdown or performance problem, it can be very difficult traditionally to diagnose these sorts of problems. So one of the major things that has been added and is continuing to grow, and at the moment it's only on Unix-based AIX and Linux and Windows for the time being at least, is this OpenTelemetry tracing, which OpenTelemetry is it's an observability framework and toolkit. It helps you to do these end-to-end application traces when you have an application where it starts out with maybe a customer using their mobile phone or cell phone to connect to their local bank maybe and do an inquiry for their account balance and then do a transaction. That'll consist of lots of things like HTTP connections, MQ puts and gets, database activity on the back end. So OpenTelemetry, or OTel as it's often called, is all about tying together that entire transaction into a unified view so that you can then measure how long each component takes and pull back the overall overview eventually. So you can go back and say, well, when this user logged in at 10:07 a.m. on Tuesday, we got reports of performance problems. You can then see, well, the HTTP bit was okay, and the MQ, the MQ put was okay, and then maybe DB2, the database or whatever it is, that took a long time to do something. So it allows you to zero in on which components are causing problems. It's vendor and tool agnostic, which means that this isn't one proprietary protocol or format. It essentially works with a broad range of observability solutions. Some are commercial, like IBM Instana, who originally did the MQ exit for us. And then there's other open source tools like Jaeger and Prometheus that they can ingest this OTel data and provide really interesting graphing and drilling down into the details of what's going on. So this is quite interesting and useful stuff. It lets you, so it helps you to diagnose these problems across multiple systems fast, because generally the problem is that when systems are so complicated nowadays that there's many different systems interacting for one single piece of work or transaction. So figuring out which of the 5 systems that a message or a transaction is passed through are causing the problem, that in itself can be tricky. So the OTel stuff really helps with that. You also get overall insights, greater insights into the end-to-end performance. So you can figure out which bits are going slow, what to focus on for performance enhancements, and help improve customer experience and things like that. It's also hopefully somewhat future-proof because it's all open source or open standards, and is very likely to become a cross-industry de facto standard for observability. Seems to be the way things are going. So the Instana exit is available on the Windows and Unix platforms, not on appliance, but on those platforms, and not on Z at the moment. And it's a shipped exit, which means that we support it, ship it, and you can use it to help gather this OTel information. So the MQ console dashboards, if you haven't looked at the console for a few years, or you've never looked at it, it started out a couple of releases ago as a very bare bones, very basic way of monitoring queues and queue managers. It's been greatly enhanced over the sort of last few years. Every sort of CD release, we add more features and capabilities. And you can now get overviews of your system and see what queues are active, what's connected, what applications are there, how many messages are flowing through, what the sort of CPU and memory are on individual boxes that queue managers are running on. So it helps you kind of get this observability of what's going on in your queue manager far more easily than having to use some sort of third-party products to do so. So you can see here, you connect to queue managers, you can look at individual queues, see if they're becoming full, check on network activity, things like that. So let's just sort of drill down and get a bit more information there. There's some new tabs that provide information on applications and the MQ network. So you can look into application connectivity, queue manager networking, whether you've got problems with your channels, and hopefully it will allow you to get a better overview of the system, and it will also allow people without deep MQ skills to at least be able to do some additional investigation diagnosis work without having to learn the detailed command line commands and how to interpret the data. So moving on to security, which is always an ongoing growing topic. We've now got JSON Web Tokens, which are an alternative to using, on distributed at least, and multi-platforms, and an alternative to using passwords and things. They allow you to use these JSON Web Tokens, which are a standardized security element that allows you to work in a secure multi-factor environment. They're token-based, so you don't need to transmit passwords around. They scale up, so you can use these back-end authorization servers to issue and administer your tokens and your authentication. And they're much more flexible. You can use them across multiple diverse applications. So you can kind of bring together your sort of security story, and the MQ on multi-platforms helps play to that. From MQ9.4 LTS onwards, we're moving away from on multi-platforms. This is CMS key stores, They've been deprecated, and we're now preferring that you use PKCS 12 key stores, which are a more common open sort of standard that helps to provide a better experience for storing keys and maintaining them. And there's some instructions there on how you can provide passwords with them and things like that whenever you're connecting with using certificates and things. These support the MQI clients and the unmanaged.NET clients. The Windows carries on using the Windows Certificate Store, and Java JMS can already use the JRE's PKCS 12 support. So that doesn't really change that. So this is really a sort of MQI clients or C clients and unmanaged.NET clients change. For containers, we now support running a read-only root file system. So it's very common with containers to build up and package a queue manager in a container. But of course, historically, those containers needed to provide write support, which meant that once you'd created a container, you couldn't be sure that something hadn't manipulated it or changed it or corrupted something within it. So MQ now supports being run within these read-only containers, which means that once you've once an MQ container has been created, it should be immutable. It shouldn't change. But obviously, you do need to be able to write things. So you need to configure scratch and temp volumes and things like that to allow it to write sort of temporary files. And there's some options there on the screen that show you how you can enable this. So it's a useful thing if that's something that you want to prioritize. So this is a strange sounding one on the face of it. We let you skip on multi-platforms the SSL certificate validation. Why would you ever want to do that? Well, one of the most common things that happens is certificates and things expire. And at that point, most of the TLS infrastructure will refuse to accept an expired certificate. However, most customers would probably say that rather than having to, turn off SSL or something, or TLS, we should say, or something to get things temporarily working while the certificates are sorted out, it's actually safer to just say, let's just skip the certificate validation. We're still using all the encryption. In theory, it's less secure. You'd never recommend anyone doing this, but it allows you a way of getting over that temporary period where you can fix some problem with your certificates. So obviously, it's not something you'd ever voluntarily do in production, but it's there if you need it. But it's also really useful as well for development and testing when you don't want to have to keep renewing certificates and things like that. You can just rely on that happening in production. So resilience and scalability. So with the multi-platforms MQ Manager running in HA, in Kubernetes and OpenShift, generally in the cloud, we now provide native high availability, which is essentially a way of running a set of queue managers that are constantly connected to each other and replicating, but they appear to the outside applications to be a single queue manager. So all this synchronization is all managed for you by the high availability solution. And what this essentially does is it keeps all the queue managers in sync. If one fails for any reason, you've got the Raft consensus algorithm that allows them to figure out between the remaining nodes which node, being a queue manager here, which queue manager has gone away, and therefore the two remaining ones can essentially vote to take over the role of being the queue manager and run in a redundant mode until the problems with the first node or the queue manager has been fixed. So it allows you to have a high availability solution running in the cloud. You can lose an entire queue manager and you should be able to carry on without too much interruption. In 9.4, we continue to enhance this model. We've done some efficiency improvements that make it smarter media imaging, copying data between them, automatic recovery of damaged objects. So if you do have a problem, say a disk corruption issue or something, and you need to get the queue manager back in and up and running to get your redundancy back, we can then help you rebuild very quickly those damaged objects and get your queue manager back in the high availability group very easily. And we've used some other additional things like the LZ4 compression to help improve performance of replication. One of the new capabilities added in 9.4.2, so this is very new, it's not yet in the LTS releases, but of course, if you're deploying in the cloud, LTS is generally not necessary as important as it is on maybe deploying things on mainframe, is we've got this cross-region replication, which this takes the thing we looked at before, which is the set of native HA queue managers all operating and keeping each other in sync, and providing a view of a single queue manager to the applications that can recover automatically. And this allows you to add async replication to another region. So, you know, as kind of yesterday showed in Spain and Portugal, you can have, you know, a couple of data centers 10 miles apart or something, and that will help you if you have a local problem or a small area problem. But if the entire region suffers some sort of larger effect, you want to have some backup capability that you can move potentially thousands of miles away. And of course, this async replication allows you to do this disaster recovery scenario. It's quite similar conceptually to the RDQMDR that we offer, but this is all for the native HA cloud. So you can choose a different region and have your sets of queue managers replicated, and you can flip between them and switch between them back and forth to give you that high redundancy, high availability solution. On multi-platforms, we've added the LZ4 compression. We talked about it briefly in the native HA to explain that we use that for more efficiency because it's a lower cost, higher in performance. It's a compression algorithm that really focuses on compression and decompression speed. So, you know, lots of algorithms over the years have tried to squeeze every byte out of the compression, and not worried maybe about the decompression speed. But when you're doing things like trying to asynchronously copy logs from region to region, then actually performance is quite important in terms of compression speed and decompression speed. So this new algorithm that we've implemented in MQ allows you to help with that communication across channels and replicated queue managers for native HA. So administration, application development. So the MQ console, what we had a little look at a little bit earlier, that shows you the web interface to look at and administer queue managers. Traditionally, that needed to be part of the MQ install. You had to all be running on the same machine, etc., etc. We now let you go and grab that MQ console and install it without a full MQ installation. So you can install it on a separate machine, for example, and now that will be able to administer various queue managers. It's designed to be backwards compatible, so you could grab the latest and greatest CD release, but still use it to administer an LTS queue manager. So you get some of those new console features earlier, and you can now configure it in a sort of scalable, highly available deployment model where you can have one or more web servers behind a load balancer sharing a common configuration to give you a scalable, fault-tolerant experience. The REST API, as we said, we've deprecated version 1, but the version 2 API is there now. That runs on the web server technology that the console does. That can now be used to interact with any queue manager in your estate at any version. You don't just have to run the MQ web server right next to the queue manager that you want to access via the API. So this gives you greater flexibility to be able to deploy the REST messaging server component more flexibly across your sort of enterprise. For those who use AWS as their sort of preferred cloud provider, we now provide sort of pre-canned MQ and MQ advanced options within AWS that you can just buy straight from AWS through their licensing system. It gives you a best practice deployment of the IBM MQ native HA queue manager. So that set of queue managers that are all replicating within each other and doing high availability, that comes as like a pre-canned template that you can then deploy on the AWS Elastic Kubernetes service platform. So it allows you to deploy, you know, a good best practice, highly available, fully functional MQ within AWS Cloud in a single click, in theory. And you will get the proven topology that we recommend for a highly available architecture, and give you resilient connectivity as well. So it's a way of getting a highly resilient, highly available set of queue managers very quickly in AWS. Some other quick updates that have been added. we've got message expiry, the cap expiry capability is now a first-class attribute. So this means that you can actually set cap expiry on a queue. For those who might not know, cap expiry allows you to force an expiry value onto a queue. So it's obviously something you don't want to do without careful thought, but typically what that will be is if an application program has never specified expiry, but you don't want them filling up the queue with old messages. So let's say they're query type messages, and after 5 minutes they have no value, and you want to get rid of them, and you've maybe, you know, in the past you've just had some automation that goes through and throws away all the old messages because if they're not processed straight away, then you don't care about them. Cap expiry allows you to set a maximum expiry, a minimum expiry interval on the queue. So you can say cap expiry, you know, 300 seconds, which means that any message that gets put to the queue will immediately be given a 300-second expiry value, which means that even without making application changes, you can force that onto specific queues. Non-production entitlement, we've played around with the licensing, and we've introduced the concept of a non-production license that you can use. Obviously, they're not intended for use in a production world, but you can use them for development testing purposes to help you manage the licensing across your enterprise. Mac OS support, Mac's becoming very popular over recent years. You can now run an MQ Queue Manager container image natively on Apple Silicon without having to do all the emulation. And of course, there's some client library support for Mac OS as well that's been introduced in the past. And there's some other libraries and AIX support, MQ supporting .NET 8 and .NET 6 libraries on these environments. Support for JMS and Jakarta, and automated workload balancing for JMS. So uniform clusters allow clients to move around a set of clustered queue managers to balance the load out from clients. And now JMS clients can benefit from that. So they will essentially connect into a queue manager, find that it's over, you know, it's too many connections are here and not enough are going to one of the other equivalent queue managers within the group, and then they can be rebalanced invisibly, so the client doesn't even know it's happening, or the client application doesn't know it's happening, I should say, so that you can rebalance these workloads and do things like quiesce and shut down queue managers and shift the workload from one server to another. So that's one of the sort of capabilities that's added there. So a lot of that was talking about distributed and multi-platforms, focusing on MQ for ZOS. We have got some capabilities like Z Hyperlink. So this is essentially a high-performance disk DASD I/O capability. Historically, the way I/O used to work, because I/O was, you know, slow compared to processors, was that an application or a subsystem like MQ would schedule something to be written or read from I/O, and then would wait asynchronously for it to occur. So the program that was waiting for the write to complete, for example, to a log, would have to give up the CPU because it, you know, couldn't wait that long, and let something else run, and then it would get dispatched again whenever it all completed. And this is quite efficient in CPU cost terms, because it makes the most efficient use of your CPU, doesn't waste cycles. However, DASD and disks have got sufficiently fast now that there is an option you can use if throughput is what you care about. You can say, I'm not going to asynchronously undispatch myself and wait for this I/O to complete. I'm going to do a little spin loop and wait for the write to complete. Now, that sounds a bit inefficient, and in terms of CPU cost, it is a little bit, because you're using more CPU cost. But in terms of throughput, it can provide some really, really significant improvements in write times. So if you are constrained by how fast you can write to DASD, for example, the MQ log, if you need to write persistent messages to a log, that might be the limiting factor for how fast your queue manager can do work. Then things like Z Hyperlink will allow you to potentially improve that quite significantly. So as I say, it comes at a bit of a cost with CPU, but it gives you more options for performance. 64-bit channel initiator. So historically, the channel initiator address space, which is the address space where all networking connections to channels and server con clients run from, has always been a 31-bit, effectively an application address space. But this limits the number of channels you can run, because a 31-bit address space will only have about you know, in theory 2 gig, but in reality more like about 1.3, 1.4 gigs of free space. So if you're trying to run lots of concurrent client connections, and it normally is clients that people worry about because they tend to have large buffers. So 100, you know, example here on the right, 104 current client connections, each sending, receiving 10 megabyte messages. With 930, you'd have to have 10 megabytes of 31-bit storage for each and every client. And that would limit you to just 128 clients before you actually exhaust the 31-bit private storage, which isn't a huge number these days. So by moving to 64 bits, we can shift most of that into 64-bit storage. And that allows you to then get up to the sort of maximum 9,999 clients connected. So it can make a big difference if you're trying to connect a large number of clients to a z/OS queue manager. And there's some notes here about increasing mem limits and things like that you'll need to do. But it's all reasonably well documented. Flexible monitoring. So for a long time, you couldn't get good SMF statistics about queue at the queue level without turning on what's known as SMF accounting trace, which is a very voluminous set of SMF data that's quite expensive to capture and quite swamps you with a lot of data. But from MQ9.4 onwards, we've added a wide range of per queue SMF statistics. Now, the statistics are SMF 115 records that are quite cheap to capture, especially compared to the accounting 116 records. But because you can now monitor per queue SMF statistics, this will, you know, make it a lot easier for people to gather those statistics on a constant or regular basis to then plug them into anomaly detection software, maybe machine learning or AI, that can spot when things are going outside of the normal boundaries and alert you nice and early. So this essentially is a way of doing relatively cheap monitoring of your queue manager queues without all the additional costs that SMF 116 would bring. And of course, it enables various things like the IBM Z operational log and data analytics tools that can ingest that SMF data. Now that we're emitting more useful data more cheaply, you can use some of those capabilities more easily. We mentioned the console already, but the MQ console has been enhanced with some Z-specific pages, things like storage classes, page sets, buffer pools, things that are very Z-specific. You can now see those, monitor them, administer them, all from the MQ console. So again, this is part of the story of the MQ console evolving and growing over time. Even though some of this stuff is maybe at 942, because you can run a CD release of an MQ console totally separate to your production queue manager, you can leave your queue managers running on 9.3 LTS or 9.4 LTS and install the MQ console at the latest 9.42 level, for example, and get all of these capabilities while still administering your more stable level queue managers. So there's a log print utility in MQ. I'll very briefly explain it because some people may never have used it or seen it or heard of it. Essentially, when MQ writes messages to a log, to use persistent messages to a queue, it will always log them in the MQ logs, the active logs, which then become archive logs that are all used by MQ for recovery. Well, the CSQ1logP utility allows you to format out data from those logs that have been written in the past. And it allows you to do things like go back in time and say, last Tuesday we had some problem that occurred or something. I want you to go and, you know, list all the messages that were persistent messages, because non-persistent messages don't get logged, therefore they're not here. Go and show me all the persistent messages between 9:30 and 9:35 on Tuesday and things like that. And there are various ways of operating it so that you can extract data in a slightly more friendly format. You can actually use, there's a tool called a sample called CSQ4 logs that we ship that can actually take the output from CSQ1logP and replay it. So if you have some sort of disaster where you lose all of your, you know, page sets for some reason, and you need to rebuild a queue manager, you can go back and grab the archive logs and active logs and replay messages if you need to. And people use it for things like test purposes to replay real production workload in a test environment to give them a more realistic set of data and things like that. So the enhancement we made here is that we now support message properties there, so that messages that have like RFH2 message properties are also processed by CSQ1logP, whereas in the past that wasn't something that the tool could do. So moving on to the MQ appliance, there have been some capabilities here that have been added. There's a file system usage monitor on the appliance that allows you to keep track of the file system on the appliance at a configurable interval. It generates log events that can be forwarded onto monitoring tools like Splunk or Elastic Stack. And it allows you to essentially improve the monitoring of your appliance devices. Because that's something that's not always very easy to do, because they tend to be these boxes that you just enable, switch on, connect up, and then you almost forget about them until something goes wrong. So this allows you to keep track of what's going on within them, certainly from a file system perspective. There's also been some additional enhancements, like the ability to use SSH connections with passwords and certificate management. So you can now SSH in using traditional Unix capabilities, especially with certificates. You can use CA signed certificates to simplify automation and to provide more secure and reliable ways of connecting and authenticating without using passwords everywhere. And it also includes capabilities to do things like revoke user certificates, etc., etc. Much like the disaster recovery we talked about with the native HA, you also have the capability to do a very similar thing with the appliances, which is that you can have two different sites where you've got multiple appliances that are replicating synchronously with each other for high availability. And then you can have a separate physical site that's located some distance away where you do disaster recovery async replication to another, HA replicated synchronous set of appliances. So essentially, you've got high availability in each site because you've got some redundancy there, and you've got the capability to asynchronously replicate to a second site or subsequent sites at greater distance to allow these sorts of disaster recovery scenarios. In both HA groups, they can have active queue managers, and you can actually have some of them active at both sites. But if one site fails, then all the queue managers can become active at the remaining site. So it gives you sort of various options for providing high availability solutions when using the appliance. Each HA group can have a floating IP address, but you can't share a floating IP address to span multiple sites. Secure backup for the appliance allows you to use the same capability that if you've got a data-powered gateway, that has the same thing. Essentially, it allows you to take a backup of your system settings, local users, certificates, everything you need to kind of rebuild an appliance and push that out into a secure backup that is encrypted, so that it doesn't expose potentially security sensitive information in an unencrypted file. You can then restore that same backup on either the same or a different appliance, and it helps avoid the need to back up lots of individual resource definitions. But it doesn't include the queue manager configuration of data. These are backed up and restored separately, but it does give you all the appliance configuration. So insight into business events. So MQ and Apache Kafka are two messaging solutions, but they're quite different. Kafka's more about event streaming, high volume for data caching and processing. IBM MQ is more about critical exchange of information from one system to another, making sure that the messages must get through. So those provide very different patterns for people depending on what sort of work you're doing. So, event streaming, where you want to stream out huge amounts of data and keep it available, MQ isn't really designed to do that, whereas Apache Kafka is. But equally, you may not want to use Kafka for reliable transactional messaging because it's not really what it was designed to do. And somewhere in between, there's this concept of having real-time event notification for microservice scalability, which really is an overlap where they both work together, can interoperate to allow you to get the best of both worlds there. So we have good integration nowadays with Apache Kafka, and we have these concepts of having the ability to flow data between Apache Kafka and MQ. We've got new assured delivery sync and source connectors. So we've had Apache sync and source connectors for a while now, but they didn't have the delivery assurance promise that comes with the current levels of the source connectors, and they allow you to essentially integrate MQ and Kafka in various ways. You can just take applications and put messages to queue that will be extracted and taken to Kafka. You can use PubSub to have applications that publish messages to multiple destinations, have one of those be a Kafka source that allows you to push data out into the Kafka world. And you can also use the MQ streaming capability that was added in recent releases, which allows you to essentially clone a queue. So MQ will take all the messages that get put to a queue and create a second copy of them. And you can define that to be a Kafka source. So essentially, you take a copy of all the messages flowing through your MQ network, and if you want, you can make a clone of those that essentially go into Kafka. So the key thing here is that these are now supported connectors that are part of the MQ Advanced. Supported meaning that you can get IBM support with them. If you have any problems with them, we will fix them, etc., etc. And they now give you the most recent version of the connectors supports this exactly once message delivery paradigm to help prevent message duplication if you get these Kafka Connect failures. So that was a kind of whistling through all the various things. I apologize if I kind of raced through a little bit there. Quite a few things. There was quite a lot of things to touch on. In any sort of what's new, there's only so much we can do to talk about things in any great detail. So, if there's any questions, then we've maybe got a minute or two to take them.
Yes, thank you very much, Neil. It's a great presentation, and I know it's packed with information, but it's very useful and very technical, so appreciate that. So far in the chat, we received one question, but since we have a couple of minutes, maybe the asker can want to ask it himself. Let me see. I have allowed people to unmute themselves. So Radek, if you want to ask the question yourself, please.
Or maybe you can't unmute, but I can see the question in the chat, which is essentially, in order to get the 64-bit capability in the MQ Chinit, is that something you have to configure, or is it the default behavior? And it is the default behavior. So you just will be able to get 64-bit capability with the 9.4 Queue Manager. So it's the new normal for clients. But it's worth emphasizing that it is just for server cons. If you've got, for some reason, thousands of point-to-point sender-receiver type channels, they can't at the present time benefit from that. But nearly everything we heard that was concerned about storage constraints was coming from people connecting clients in. So that's why that's the first thing that we've done there.
Brilliant. That makes sense. Thank you very much.
Thank you.
Oh, thank you, Radek. Yeah, finally got it on mute. Does anyone else? I mean, we have 1 more minute for questions. Now is your time. If you want to unmute yourself, anyone should be able to unmute themselves. But also, just to mention, Neil has left his contact details in the session overview. And hopefully, I'm not over the term saying that, Neil, but MQ team is normally very open to questions outside of the conference as well.
Yes,
so,
feel free to email me.
So yeah, the information is out there for you guys if you don't want to ask just now. But if no more questions, let's wrap up. Once again, Neil, thank you very much for the information. As I mentioned earlier to you specifically, but just to mention to everyone else, the session has been recorded. So if anyone wants to review it again, because there was a lot of information, a lot of useful information, and if they want to share it with their teams, they will be able to. But apart from that, the time has come. We now need to wrap up. So thank you once again very, very much. We had good attendance. We had a really good presentation. So appreciate your time, Neil. And hopefully to see you in the future GSCs.
Thank you. Yes, hopefully I'll get to come along. So thank you, everyone.
Thank you all. Cheers all.
Bye.
Thank you so
Bye,
much.
bye, bye, bye.